Okay, yeah, let's go. How's it going? Let's go ahead and get into another Leetcode problem. Today I'm going to be doing the jump game number 55. Seems kind of cool, so why not? Let's go ahead and let's go ahead and read it. So given an array of non-negative integers, okay, you are initially positioned at the first index of the array. Each element in the array represents the maximum jump length that you can move at that position. Determine if you're able to reach the last index. Okay, so this one's true because if we start here, we can jump at most twice. Yeah, so we can either jump to 3 or we can jump to 1. But if we jump to 1, we can jump one time. We just jump to 1 again, and then from here we can jump to 4. Okay, cool. And then this one's false because if we jump 3 times, 1, 2, 3, can't jump anymore. Okay, let's jump twice. So 1, 2, can jump once at most, and we get back to 0 again. And if we jump once, we go here, then we can jump twice, 1, 2, or we can jump once, 1, and then that'll still put us at 0. Okay, that makes sense. So let's see, how do we do this? So I feel like this can be done linearly. So if we're at 2, we can just 1, 2, and if that jump, if it's greater than 0, and the next element isn't 0, no, there's a better way. What if we go backwards? Let's see, that makes sense. So if we have 4, we can check the last element, and if this one can get the 4, then we're still good. Then we go here and we just check if this, I think that might work. Let's see, so 4, so we'll go to the last element, this one. Oh, that might work. So let's do that. Let's go backwards. So we'll create an integer called, I don't know, good index, and we'll set that equal to the last item, right? So whatever the length is minus 1. So for this case, it'll be 5. So 4, 0, 1, 2, 3, 4. Should be minus 2 because we want to get to here. We'll figure that out. Okay. So now we want to loop through the entire thing, but we want to start at the end because we're going backwards. While I is greater than 0, greater than or equal to 0, and then we're going to decrement, right? Yeah. Okay, so if we're going backwards, Oh, okay, so yeah, we can start at the end. So this is our last valid one. Then we got to check, is this one also valid? So we can do like if nums I is greater than or equal to 0. Yeah, no, if it's greater than or equal to 0, yeah. And nums I plus so let's say we're here. So if nums I is greater than 0, that works. So that's 1. And if 1, no, let's go here. Let's do this one. So if this one is greater than or equal to 0, which is true, and if this one, this value, yeah, getting lost in the sauce. Okay, so if we're going to start at the end, we're going to start at 4. We're going to say if 4 is greater than 0. This is so far good, but doesn't matter since this is the end. So if it's greater than 0, and if the value that we're at, so this one plus the value of our last good index. Yes, right? Yeah, I think that might work. The value of our last good index is greater than or equal to the length of the array. I think that might work. That might work, right? So if we're here, if this is greater than 0, that's true. And if 1 plus our last index, which would be this one, because this one's also valid. So if those two combined, 2 is greater than, oh, no. No, yeah, that might work. So in that case, we're gonna move our index to be this. So loop through backwards, starting at 4. If 4 is greater than 0, and if 4 plus 4 is greater than the length of the array, that's true. Okay, then we set good index equal. I feel like we should start at right there. We should start at this one. Yeah. So if 1 is greater than 0, and if 1 plus 4, so if these two combine are greater than the length of the array, or equal to, that's true, it's 5, then we're going to set the next good index to be this one instead. Then we loop again if this is greater than 0, and if 1 plus 1, no, that doesn't make sense. So over here, we can just say, what if we did that instead? So if 1, oops, take this away. Oh, wait. We can do, nope. So if num's I, so if 1 plus this one, so which is 2, is greater than not the length of the array, but the index. This isn't going to be I, or num's I, this is going to be that. Right? Yeah, it has to be that. That's the index. Oh, I'm confusing myself. Okay. So we're going to start at 1 if 1 is greater than 0, and if 1 plus 4 is greater than 4, then good index is going to move from this one to this one. Then we're going to say, okay, if 1, again, is greater than 0, that's true. And if 1 plus the value of this one is not greater than the index. No, we don't want to do that. What if we just checked if it was greater than 0? Because it's greater than 0. No, but there might be a case. If num's I, how much time? 9 minutes in. Come on, we can do this. So if num's I, or num's good index, so that should be that one. So 1. What if we just did, what if we did I plus good index? No, it has to be the values. It has to be the value. So if this is our last good index, so if this one plus our previous, which is going to be num's I, if that is, so if these two combined Oh, whoa, we can just say if num's I is greater than or equal to num's good index, right? Because then num's I is greater than or equal to this one. So then this, yeah, okay, and then all we have to do is check if good index is equal to 0. I think that might work. I spelled index wrong. Let's see. Ew, that did not work. So else good index equals 0? No, I can't do that. Okay, so if we're gonna go backwards, we'll start at the end. So let's just change this back. Let's delete this. Let's just restart. Okay, we're here. We need to check if this bad boy is greater, if this bad boy, so if 1 can reach here. Oh, we gotta check the index of that one. So if nums I plus I is greater than or equal to good index, reassign good index. Right? So we'll get here. We'll start at the end. We'll start at 4. And we're going to say, okay, is 4 plus the index of 4, which is 0, 1, 2, 3, 5, is that greater than, yeah, that is. Okay, so good index now equals, this 1, and then we'll say, okay, if 1 plus I, which is 0, 1, 2, 3, is greater than or equal to good index. I think that might work. Let's try that. Oh, look at that, people. And that is how you do good jump, right? That's what it's called. Jump game. That's how you do jump game. Cool. Yeah, nice. Wow, I was really concerned about that one. Let's submit it. Oh, I'm not feeling good anymore. Oh, woo! All right, there we go. That's how you do good jump. All right, nice. Yeah. So let's go over that one more time. So, so right now, good index is going to be equal to 4 right at the beginning. Okay, so we're going to loop from 4 backwards to 0. Okay, so we're going to say if nums I, which is 4, so if 4 plus 0, 1, 2, 3, 4 plus 5 is greater than 4, set good index equal to I. So then I is going to be equal to 4, so 0, 1, 2, 3, 4. Oh, I just kept doing that. Wait a minute. Did I get stuck in this loop or something? I is equal to 4. Oh, it's going to get decremented down to 3. I'm silly. Yeah, it gets decremented. So then it's 1. So then we're going to say, okay, if the value at this index, which is 1, plus the index itself, so 0, 1, 2, 3. So 1 plus 3 is 4. So if 4 is greater than or equal to 4, good index equals this one. Nice. Okay, so then we're going to do the same thing. If 1 plus 3 is, which is also 4, so if 4 is greater than 4, set good index equal to this. So then good index is here, and then we're going to say, okay, if this value, 3, plus the index that we're at, so 0, 1, if that's greater than or equal to 4, 3 plus 1 is 4, continue. So then we're here, and then we get, okay, if 2 plus the index we're at, which is 0, if that's greater than or equal to good index, which is not true. So this doesn't happen, so good index stays, I believe, right there. And then we just check to make sure good index isn't equal to 0. Cool. I think and I think if I run this, good index should be 3. That's it. But yeah, that's how you do it. Nice. What's our time? Oh, right under 15. All right, peace out. I'll see you in another video.